Okay, anybody have any problems with building a causal graph? Easy stuff, yes? Good. Okay. I now want to move on. Yes?
Before we can decide on which group, can we have a brief overview of the different groups?
Sure. We can do that at the end of this session. So can people, is Takas still here? Did he leave? Takas? No, he's maybe left. So we'll try to get that for you by early this afternoon at the latest. Okay. Okay, so the next thing I want to cover is, now that you've actually seen how incredibly simple and easy it is to model a causal graph, to build a causal system, let's talk about what it is that really gives these things part of their causal interpretation, which is modeling an intervention. Right? So when you think about what is an intervention and why does it actually matter, here's a simple example that should make it reasonably vivid. Right? If I have a system that says the room temperature, right, is a cause of whether or not you're wearing a sweater, right? I think you would all agree that's an actual causal relationship. And I say, okay, well, how does that manifest itself, right, in terms of a response to interventions that I might do? And how does that actually get modeled? Well, in the pre-experimental system, we say room temperature is a cause of whether you're wearing sweaters. And if I flip a coin and I actually make you take a sweater off or put a sweater on the basis only of that coin, so I take all control for what you're wearing out of your, right, your hands and make you follow the experimental regime, then I can represent that by a pair of dice, right, going into whether you have a sweater on, and then what's the response of the system to that intervention? Well, the first thing to notice is that that will eliminate the influence that the room temperature previously had upon whether or not you wear a sweater, right? You're wearing a sweater if you're cold because you want to be comfortable. You're taking a sweater off if it's hot because you want to be comfortable. You are no longer allowed to decide your sweater wearing behavior. That is the right province of the coin flip or the die, and that's all it's a province of. So any influence that room temperature had on your sweater is eliminated. And in the post-experimental system, right, we have now changed the causal system and changed the relationship between room temperature and sweaters. So consider the same system, but now let's intervene upon the cause, not the effect, right? So I'm going to randomly set the room temperature, right, to 55 degrees or to 95 degrees and let you guys decide what to wear all by yourself and ask myself, after I do that experiment, what's the description of the causal system post-experiment, right? It's the same thing as pre-experiment, because although I might have actually changed, right, the value of the room temperature or the distribution, I have not changed the relationship between room temperature and sweaters. So you're still going to wear a sweater, right, if you're cold, and take a sweater off if you're hot. And so there's an asymmetry here. When I actually do this kind of an intervention on the cause, right, I leave the relationship between the cause and its effects intact, even though I might change the cause. But if I do an intervention on the effect, I change the relationship between the effect and its causes. I take over. I eliminate other influences that might have existed prior to my intervention. So really that's the basis for modeling what happens in intervention in this field, right? Changing the structure in response to an intervention. Okay, any questions on that? It's lots to say about it, but that's simple. So if I start with a pre-intervention graph, such as this one, where education is a cause of income, and income is a cause of how much taxes you pay, right? And I say, what would happen to that graph if I did an intervention on income, right, where I flipped a coin and my coin flip completely determines your income value. So for example, I might say, coin flip comes up heads, right, you get an income of $50,000 a year. Comes up tails, you get an income of $250,000 a year, right? Whatever you were making before that, right, is irrelevant. That's your income, right? That's called a hard intervention, right? And it's sort of the paradigm of a randomized trial in medicine, where you don't get any say over whether you get the placebo or the experimental drug. It's determined by the coin flip and only by the coin flip. And how do I model that? Well, I have this little extra thing, I, to represent the intervention that I add to the system, and I eliminate everybody that was previously influencing the thing that I am now targeting, right? So the response of that pre-intervention graph to a hard intervention is right here. Simple enough. Now, it's very important to point out that that's not the only kind of intervention that might happen. There's many, many other kinds, in particular what we call a soft intervention, right? So if instead of flipping a coin and then intervening to determine your income completely, suppose I flip a coin and if it comes up heads, right, I add $10,000 to your income. And if I flip a coin and it comes up tails, I add $50,000 to your income. So in that kind of intervention, I have not eliminated the influence of education on income. I've changed the intervention. I've changed that relationship, but I haven't eliminated it. Education level still is going to cause your income, but now my intervention is going to add either 10 or 50 to it. So that's called a soft intervention, and graphically I can represent it like this, where I don't change it, right, by eliminating it, but I change it quantitatively or parametrically. Okay, any questions on that so far? So in what follows, I'm going to, by default, be referring to hard interventions when I say manipulation or intervention, unless I'm a little more careful and make my language precise. But if I don't, then you can assume what I'm referring to as a hard manipulation of the sort we do in a randomized trial in medicine. Okay, so now I'm going to ask you guys to get active. Take out your pens and papers. I'm going to give you exercise, but first I'm going to answer a question.
Does an intervention always happen on a variable that's inserted on any of the?
No, not necessarily. So that's a great question, right? Sometimes, for example, if I'm saying, okay, I'm looking at whether smoking causes lung cancer. So I do an intervention, and my presumption is that the intervention is on smoking. But the usual intervention is on something like, I tell doctors to tell their patients to stop smoking. So my intervention might be a letter to the doctor, not smoking, right? The doctor might tell the patient might say, oh, okay, I should stop smoking, and actually stop smoking. And the patient might say, I'm not going to be bothered, or I try, but I can't. So that's a subtlety that we have to model also. And in most cases, when you think about what the intervention actually is, right, it rarely actually completely changes, right, the target itself. Now, if you're talking about a drug, right, and you're in a trial, then yes, that intervention is going to be effective at giving you, right, if you're monitored and you're watched to take it or it's injected or something, the trial will make sure that you're getting the experimental or the placebo, and there's no doubt about that being a hard intervention. So, but it's a very subtle and difficult thing to represent all that quite carefully, and I want to make sure that I don't gloss that over and say this is all easy. It's not.
And are interventions also performed on latent variables as well?
Well, if you perform an intervention on a latent variable, then it's hard to sort of measure what you've done, right? In some cases you can do that, but yeah, sure. Sometimes the interventions you assume are going to be influencing latent variables, and you have to indirectly find a way to measure what you've actually done. Yeah. Yeah. Wait, where's the question? Yes, sorry.
Intervention in reality? Is it through the randomized trial?
That is the paradigm case. So, I'm sorry. So the question was, how do I realize a hard intervention in reality when I'm doing science? And again, I think the model is the randomized trial, right, in medicine, and we try to make that double blind, right, so that the thing that determines what the treatment is completely separated causally from the person administering the treatment, the person getting the treatment, the person measuring the effect, et cetera, et cetera. It's completely random. And then we also make sure that all sorts of other protections are in place. But the basic idea is that the thing that you're actually treating, or placebo, right, is the variable that you're trying to find out whether it causes some response in health or not, right? But in many, many cases, right, when you're trying to do some kind of an intervention, it's very difficult to make the assumption that this is a hard intervention and I've really actually determined the value or at least the distribution of a certain variable. Right? Sometimes I've done something proximate to it, but not the thing itself. And I think smoking is a great example. I can't really change people's smoking behavior. I can do other things that hopefully will result in differences in smoking, or hopefully result in differences in lifestyle, etc. Right? But the intervention is typically not in lifestyle. It's in information you give, or in incentives you give, or etc. Okay. Take out your pencils. So I'm going to give you a couple of exercises to make sure you get this nailed down. Get a piece of paper, write down that pre-intervention graph, and then figure out what you think happens in the case where I do a hard intervention on both X1 and X4, but I do a soft intervention on X3. Yeah, Lizzie?
And if you have the slides open, close them, because that's cheating.
Yeah, don't cheat and look at the slides. Now that you told them, now they're going to cheat. Yeah, you're right. Good point. I forgot about that completely. And I'll give you 2 minutes.